Welcome students to this series of lecture on LangGraph. And in the series of lecture of LangGraph, we are going to move forward in our journey and start the discussion around short-term memory and in more practical and production-oriented way. So what we did in the last session, let's have a bit of recap. See, we implemented short-term memory. We implemented short-term memory with RAM level persistence. And today we'll briefly recap that and then directly move into a more important concept that how to implement short-term memory with durable persistence. Okay. And along the way, we'll also answer like three critical questions. What exactly is durable persistence? Why do we even need it? And what are the different ways to implement it in LangGraph? Now, very quickly, let's revise the previous session. We said that, and when we implemented the short-term memory using RAM persistent, we relied on three core concepts provided by LangGraph. The first was state, the second was checkpointers, and the third was thread ID. And on the top of this, if you remember, we used InMemorySaver class to implement a checkpointer or pass the checkpointer object in the checkpointer, which have core capabilities, four core capability, like getting the data, fetching the data, updating the data, and deleting the data. When I say get the data, it means that you're trying to save the data. Fetching is like you want to retrieve the data. Then you update the data and delete the data. And when I'm saying data here, I'm talking about checkpoints, which is basically the snapshot of the states. Okay. Now, this was in itself enabled us to simulate or make an illusion of memory inside our application. That's what we did in the last session. Now comes a shift. We want to implement this same short-term memory. We are not talking about long-term memory yet. We are talking about short-term memory, but this time with durable persistence. What durable persistence? What durable persistence? But before jumping into the code, there are just two important things that you need to understand. There are different ways you can implement a durable persistence. And in LangGraph, there are two primary options. One is SQLiteSaver and another is PostgreSaver. This one is very popular because it is recommended by LangGraph. Both are officially supported, and from implementation standpoint, there is no difference. There is hardly any difference between whether you will implement SQLiteSaver or PostgreSaver. So the choice is not about how to code because we'll see in a minute that the code is exactly the same. Only the difference would be in the library or the class that you are importing. That's all. The difference or the choice depends upon where you are deploying it. If you're working locally, for example, when I do any research on LangGraph or when I build LangGraph application, I use SQLite because it's very simple. It is very simple to install. It is very simple to use. But if I would have been working in a production system, then I will prefer Postgres Saver class or the other option, which is Postgres Saver. Now, a very, very different insight that also I want to give. There is also, as in PostgreSaver is a recommended approach from LangGraph, we know that. But there is a challenge that I face, and that's why I prefer not using it, is its installation. You will encounter many different issues while installing PostgreSaver in your system. For example, dependency issues, setup friction, environment related bugs. But once it is installed, it works smoothly without any breaks. So, as a suggestion, I would say if Postgres works, great, use it because that is recommended by LangGraph. If not, SQLite is a solid fallback and you can use SQLite directly. Okay. Now coming back to what was the problem with RAM persistence. The problem with the RAM persistence was that, which we didn't spend a lot of time in the last session, is that in the previous discussion, everything worked fine, but we didn't do something or we didn't discuss about something that what if system restart? What if kernel restart? The moment your application restart, your kernel resets, or your service crashes, all the memory about user 1, user 2, user 3, everything will get wiped out. That means your user conversation, the conversations are gone. the context are lost. So the system will start again behaving like that they have never ever interacted with the user one or user two. And please, I think it's pretty obvious that this is not acceptable in a production level system, right? So what is the real need? And what should we do actually? We need a durable system, a system where memory survives even after restart, even after failure, even after any critical bug. This is exactly why we move from RAM, why we are moving from what? RAM to a durable persistence through SQLite or Postgres. So what we are going to do next, we'll first open our Jupyter notebook and we'll try to feel, first thing, we'll try to feel the limitation of RAM persistence. Whatever we did in the last session, we'll reset our kernel and see whether our LangGraph, our application can remember us or not. And then we'll implement short-term memory using SQLite. Second step. And third, if you want to implement PostgreSaver class instead of SQLiteSaver class, then you will see there is no difference between the two. That is what we are going to do in this session. So let's jump directly into the code. Okay, this was our code from the last session. So in the last session, we implemented short-term memory with RAM persistence. Perfect. Okay, so this was our model, a llama model. These are requisite library. Okay. Now for short-term memory, we need some of the components of persistence. Perfect. That are state. So this is our node, one of the node. This is where I'm passing my state. Inside this node, I'm invoking my LLM, which is llama model. So here I'm creating a state graph object, passing the state. Okay. And here I'm adding the nodes and edges. This is my InMemorySaver class. This is the object. And while compilation, I'm passing the checkpointer. Perfect. Now we created config1 for user1, config2 for user2. Here I'm invoking my discussion or communication or call with LLM and passing config1, which is associated to user1. I'm providing my name, Saurabh. What is my name? It would respond, hey, your name is Saurabh. This is what we implemented. And we also seen that there is no information about user2, about his name. That's why it is saying I don't have any information. Okay. Now what if I restart the kernel? If I restart the kernel or reset the kernel, the question is, will my LAN graph or will my application remember user one name, that is Saurabh? That is what we have to check. So let's see that. I'm restarting the kernel. I restarted the kernel. Perfect. So I'll run the initial few commands. Okay. Now I'm not providing my name as an input. I'm not providing this context because my expectation from the system is if user one again interact with you, with my system, my production level system, it should remember user one name. That is the expectation. So I'll not provide this context. I will directly ask my name. What is my name? And I'm providing the information of user one through config one. Let's see what is the response. And the response is I don't have any information about your personal details. Weird. Nobody wants this production level system that if the system crashes or if I shut down the system, if I log out the system will not remember about my conversation with the system. I don't want this kind of production level system. So what is the answer? The answer is instead of saving your information about user one, user two, user three, you should store it somewhere in a durable persistence. And that durable persistence we will implement first through a class that is SQLiteSaver. Okay, that's it. Okay, what will change? So instead of passing the object of InMemorySaver while compilation, I will pass the object of SQLiteSaver. This is the object of SQLiteSaver during the compilation of my graph. See, this is the object of SQLiteSaver. That is, I'm passing as a value to the key checkpointer when I'm compiling my graph. That's it, nothing else. And the function will work as expected. Perfect. So let's check it. So in the previous conversation, I have provided information about a user. The name of the user is 2, only 2. And I've already provided this information. So I'm asking again, what is my name? So definitely it will respond the name and will say your name is Saurabh. But if you want to see it in action, let's see, I'm creating a new user. Okay. And this user is interacting. Hey, my name is Sinha, or my name is Saurabh Sinha. Perfect. My name is Saurabh Sinha. This is the first interaction of the system with the new user. Okay. If you want to check whether this is the first interaction or not, you can also first ask, what is my name? To check whether we have already information about new user or any interaction with new user or not. Let's see. I don't have any information about your name. Now, what I'm doing, I'm providing the information. I'm providing the information. My name is Saurabh Sinha. Okay, I provided that information and I got the response. Okay, hello Saurabh Sinha, it's nice to meet you. Perfect. But now what will happen if I reset the kernel? Will this application will remember my name or not? So let's restart the kernel. So let's reset the kernel. Okay, definitely before running this, I need to build my state nodes, right? Now, I'm not using InMemorySaver. I'm directly falling to SQLiteSaver and the object related to SQLiteSaver. Perfect. Now, our expectation is in the last conversation, before we reset the kernel, we already provided the information that my name is Saurabh Sinha. So now I would ask, what is my name? What is my name? Perfect. And let's run it. Our expectation is it should respond that my name is Saurabh Sinha. And it did that. And the reason is this SQLiteSaver class is actually storing your information, your conversation through a thread ID new user in database, in actual database. How it is doing it? It is doing it with the help of this SQLiteSaver class. So this is a class which is a checkpointer class. When I say checkpointer class, even InMemorySaver, it was a checkpointer class. Checkpointer class responsibility is to save the checkpoints, or the responsibility is to fetch the checkpoints. Responsibility is to update the checkpoints, and the responsibility is to delete the checkpoint. What are the checkpoint? Checkpoints are the snapshot of the state. Perfect. So SQLiteSaver has a responsibility to save, retrieve, delete, and update memory or checkpointers, or the snapshot of the state. Check SQLiteSaver also has a responsibility to connect to the database. How it does it? It does with the help of this from const string. It creates or link the system to the actual database. What is this? This is the name of the file, or this is the name of the table, or this is the name of a, a memory space. You can simply treat it as a file name in the database. It is a file name in the database. So the name is checkpoint1.sqlite. You can also change the name. And this is the object of the class SQLiteSaver. So you can directly write the class like, hey, memory is equal to SQLiteSaver, right? So this is an object of the class SQLiteSaver. Perfect. Okay. And this command with is also very important because it actually ensure that the connection has been properly established. So with the class SQLiteSaver, use from const string to connect with the database, create a file that is checkpoints1.sqlite as memory, and pass this memory while compilation. That is what is happening. Rest everything is identical to what we have already discussed. Okay. One thing to remember, if you change the file name, for example, if you change the file name to 1 to 2, then this is another file name. And in that file name, there is no discussion about the user. So when the database connection happens and when the SQLiteSaver function start fetching the information, they are looking into this file. They will never have the information about thread ID new user, right? So you will not receive a response. See, I don't have that information. So it is important that whatever the name of the file you have mentioned there, that should be static. You cannot keep on changing that unless it is required in your system. Perfect. See, you got the response. Your name is Saurabh. So even the system crashes. Leave about the system crashes. Even right now, I shut down my system. I shut down my terminal. I shut down my Jupyter notebook. Doesn't matter. If I restart my system, if I restart my terminal, I open my Jupyter notebook and run this command, it will throw my name as Saurabh Sinha. That is what you want, right? In a production level system. Now you will say, sir, but LangGraph recommend PostgreSaver. Okay, let's see what I have done. Instead of using SQLiteSaver, just use PostgreSaver. That's it. Instead of using SQLiteSaver class, use PostgreSaver class. Rest from const string is constant. It is not changing. This is helping you to connect to the database. Now this is something you have to keep static. This link has to be static. Okay. The rest, everything is same. There is no difference and it will work for you. So if you want to use PostgreSaver, there is no difference between implementation or coding wise in SQLiteSaver or in PostgreSaver. Perfect. So please understand, we have completed the implementation and all the needed theoretical concept related to short-term memory. Short-term memory had two components, short-term memory with RAM persistence. We discussed that. How you implement short-term memory with RAM persistence? You will only use InMemorySaver class. That's it. And you will pass the object in the key checkpointer while compilation. Done and dusted. Now, the second part was short-term memory with durable persistence. So instead of InMemorySaver class, you will either use SQLiteSaver class or you will use PostgreSaver class. That's it. Everything is identical. Perfect. With that, I'll pause here. Thank you. Have a nice day. In the next session, we'll start the discussion of long-term memory and we'll see long-term memory with RAM persistence and long-term memory with durable persistence. And it is much complex discussion than short-term memory because there you have to identify the user. You have to give the identity to the user, not a conversational history or conversational memory required there. So with that, I'll pause. Thank you.